Hi YouTube, welcome back to another video on Fortran. In the last couple of videos we looked at how to get our file or set up a new Fortran project, insert a file, and from a template we got a hello world project or a hello world program, and we just modified it by adding these keywords in here of program and end program. What we're going to look at now is declarations on variable types. There are not many variable types, and from my reference manual that I've got here you can see that we have integer, real, double precision, logical, complex and character. Now I'm going to deal with just three of them for the moment, and we'll deal with double precision, complex and logical at a later date. So let's start off, because there's another little thing with variables that we have to take a look at as well, which is called implicit. So we'll take a look at that in a moment too. But what I want to give you an example of is variables. When a Fortran program is started, it actually sets up default values, if you will, for variable types. So I'm going to show you something here. I'm going to put in a equals well, let's go 4, b equals 5 and c equals 6. Okay, now all I've done is I've set on there that a is equal to a value of 4, b is equal to a value of 5 and c is equal to a value of 6. Now what I'm also going to do is now do a print command. Ignore the star, the asterisk for the moment, because we'll deal with that later on in some of the later videos, and we'll start dealing with that when we come to start writing files and text files, etc., and reading them back. So for the time being, the asterisk, just assume that it means take it to the screen, print whatever I'm going to put after the comma to the screen. So if we do a comma b comma c, and I'll take the extra comma out there, if we run that program now, notice that we've got our hello world, but we've also got 4, 5 and 6. But look at the values, they are in real format. Okay, so we've got a decimal point with our, I think it's 8 zeros, 2, 4, 6, 7 zeros after the decimal point. So it's given us those values in real type. Okay, and a real variable is obviously a value that has a decimal point and values after it, after the decimal point. But what I want to show you here is if I do 4 again for k, l equals 5 and m equals 6. Okay, so I've now added KLM, and that's got nothing to do with the aeroplane company. It just happens to be the 3 that we're going to put in, and I'm going to put in just another line again of print asterisk comma k comma l comma m. Okay, now we'll run this again. Now notice what we've got here. We've got our first variables that we printed, which was a, b and c, and they're still in real. But we've got our KLM, and they've come out as integers. Okay, and an integer, as we know, is just a whole number with no decimal places after it. So what's going on here? When Fortran originally sets up and runs a program, the variables that you can use, it will generally set to be a real value. Okay, however, there are a few variables, and in this case our KLM, which have been preset to be integers. Okay, which is all well and good, but as Fortran is more of a mathematical and scientific and engineering based programming language, those letters can be a bit of an annoyance if you are going to write an algorithm, or you're going to write your formula that is very much based around the actual letters. So for example, if I was going to use Pythagoras' theorem, or I was going to work out the length of a hypotenuse of a right angle triangle, we generally say that a squared equals b squared plus c squared. Or if I was as I am an engineer, electrical engineer, I would be using voltage is equal to current times by resistance, so it would be V equals I times R. By using those letters in my program, that's great, because as an electrical engineer it makes sense to me to use that. But I can come across problems because of these pre-settings of either a real or an integer. So I could accidentally use an integer when I really needed to know what the decimal points were. So what we're going to do, I'm just going to comment these out for the moment. Now what we need to do is declare our variables. But first what we're going to do is, I'm just going to delete all of those. What we're first going to do is we have to kind of get rid of that declaration formatting. Okay, so A, B and C were real, K, L, M were integers. We need to say to the program, look, I don't want to use your pre-formatting, I don't want to use your variable types, I need to get rid of those. So we use a command or a keyword called implicit, and all of those values that have been preset to either integers or real numbers are implicit values. And we're saying now anything that you set to implicit now need to be set to not being implicit. So in other words, we go implicit none. That means remove all of the settings, the variable types that you have already preset in the program. Get rid of them. I don't want to use them. Now at this point now, if I tried to then put let's take that one off. If I try to then say A equals 4, B equals 5 and C equals 6 and try and run the program, I'm going to get a build error. Okay, and the build error shows when I click on my build errors down here that I have no implicit type. Okay, in other words, I haven't said what A is, what type a variable A is going to be, B is going to be, and C is going to be. Okay, so now I have to declare them. So after implicit, I need to say that A, and I want it to be an integer because previously it had been a real value. I'm going to say A double colon equals, oh sorry, I am wrong. Got it the wrong way around. I need to then declare, sorry about that, I need to declare the type first. So I'm going to put integer, and I can't spell it, there we go, integer, colon colon, and then A. And that basically says to me that A is going to be an integer. And then I can put, and what I'm going to do, I'm going to cheat a little, I'm just going to do copy and paste. There we go, copy, and I'm going to paste that one, but I'm going to make it B, and I'm going to paste that and make it C. So now what I've done is I've declared that A, B and C are all going to be integers, and that A is equal to 4, B is equal to 5 and C is equal to 6, and I'm then just going to print A, B and C out. So we run the program, notice there's no faults now, and where they had previously been real numbers, because I've removed the implicit type of formatting for that particular letter, I've now changed it to an integer, and bingo, there we go, we've got our values. Okay, I'm going to delete those ones, and we'll just take that one off, and what we're going to do is a very, very similar thing, or same thing in fact, to a character. Okay, so we've got character. Now the character is, to all intents and purposes, a string. Well, it is a string, but when I use the word character, the keyword character, we're going to use our double colon. I'm going to make a, my variable, now a character, but I'm going to put in a equals, and let's put in cat. Okay, oops, let's try and stick with the norm and put in, there we go. Okay, so we should say print hello world, and we should also print cat. Okay, oh, what's happened here? We've got our hello world, but we've got C. So we've only got the C from cat. Well, what we have to do with a character particularly is we have to tell the system how many characters we're going to expect to use. So we know that cat is only 3 letters long, but let's put 4 in for good measure. Okay, so what we're saying now is declare a character with 4 characters long, and the variable name that we're going to declare it at is at A. A is now equal to cat, and we're now going to print that out. So let's run that again. Okay, and there you go, it's now printed them all out. Now you notice that I did something earlier maybe where I used double quotes instead of single quotes. Okay, actually it makes no difference. Okay, however, the reason why most people use single quotes is because you can use double quotes within single quotes. So we've got the build, and look, I've got hello world and then double quotes inside because I wanted to highlight the word world. Okay, so you tend to use single quotes, or at least I do. Under normal circumstances it doesn't make any difference, but you can use double quotes and single quotes. Okay, so we've declared, sorry that I just kind of sidelined there. So we've declared our character, our variable as a character, and we've told it it's going to be 4 characters long, and then we've printed out our word cat. Okay, what we can also do is we've covered our integer, we've covered our character, and of course we want to now make that a real, and I need to get rid of that by declaring real, or our A as real. I've put an integer into the A variable. Okay, and if we run that, it may be 6 that we put it into, but it's printed it out as a real type. Okay, in other words, it's added the decimal point and has got our zeros on the end. Of course, I can put just a handful of numbers and run it, and there we go. Okay, it's added our numbers there. So what we've done there is basically created or removed any implicit types that were automatically added within Fortran. We've removed those. We're now able to declare our values themselves, okay, and make them the type of variable that we want, and we can also, oops, what am I doing? We can also then declare those variables. We can place values into them. We've printed both our hello world and our value again, and of course we just showed you here that I've commented out that the implicit types of A, B and C against KLM, whereas KLM used to be integers, they have now been removed. If I bring that print KLM back in, I get a build fail, okay, basically because I haven't declared them. Make sure that once you've used